Hey guys, welcome back. Today, in this video, we're going to be talking about energy. We're talking about energy. Unfortunately, it is not your E equals mc squared that we're going to be talking about today. However, we are going to be talking about classical mechanics energy, which that can be potential energy, kinetic energy. All right. Now, potential energy can subdivide in two forms. It can gravitational and spring potential energy. All right, and I'm going to explain what each one of them means right now. So, and give you a brief example. So, for example, the potential energy, gravitational one, that is usually stored in heights. And I'll give you a brief example soon. And the formula for this is mgh. So pretty much the force of gravity times the height. The spring potential is stored in spring when the spring is compressed or stretched, and the formula is 1/2 kx squared. Now, the way you can remember this as potential, it means it's pretty much not doing anything with that. So, have you guys ever heard the phrase like, oh, that person has so much potential, but they don't use it? That's what it means. So it just means that they have the energy, that they have the ability to do it, but they're not using it. So the same thing is here. So this is energy that exists, but for the most part is not being used. All right? So now then we have kinetic energy, which we didn't talk about so much. But kinetic energy is found when an object is moving. So movement. All right? So the formula for that is just 1/2 mv squared. All right? So now I'm going to give you guys a really brief example of each one of them. So here, as you can see, this is a hydro plant from way ago, how they used to do it. So the water would come from here, the water flow would be coming out from here. And notice that it has a certain height, right, from the ground. So then it has an energy. We said it has potential energy, gravitational, right? So then we just have to multiply it m times mg, and we find our potential energy. That, interestingly enough, that energy, not to be wasted, is making this wheel turn around, right? And then the water, of course, come down here. But now this wheel will actually go spinning, and that energy, part of the energy, mgh, is being used in order to store energy from here, which I'm not going to go into so much of the mechanism of the plants because it's a little bit confusing and out of scope for physics. I can explain it, and if you guys want me to, just shoot me an email or just comment below about it, and I'll make a video explaining the mechanism and everything, how it works in the simplest way I can think of. But for the most part, you just need to know that if it has a height, it has potential energy, gravitational, and most of the time that was used to create electricity, right? Another example of potential energy going into kinetic energy, because here it's moving, right? So it's creating a kinetic energy for the thing that is then being transformed into electricity. Here, the guy starts at a certain height, right? We don't know, somewhere over here. So there's a height, again, and he's going to a lower part. From kinematics, as you may remember, we actually may be able to find his velocity, how far he's traveled, what the angle is. But with energy, it's a lot easier, and actually I'm going to do an example of that in the next video. But here, potential energy is getting you're losing potential energy, and it's getting transformed into kinetic energy because he's moving. So his velocity is going to be dictated by the height. And something called conservation of energy, which I'll talk in a little bit more about. But kinetic energy is just the energy of a movement. So if you guys skate by any chance, if you guys have noticed, as soon as you start picking up speed and you jump out of the skate, out of your board, out of your skateboard, if you have traveled twice as much, or if you have twice as much velocity and you jump off, it's a lot more hard. It's not just twice as hard to slow down yourself and not fall. It's actually 4 times greater. And that is because the formula is 1/2 mv squared. So if you have twice as much velocity, you're going to need to slow yourself down with a lot more force or energy for friction of 2 squared, which would end up being 4 times greater. All right, so that's kinetic energy. Now, potential spring. Again, it's just you disrupting the spring. It has no kinetic energy or potential right here. You stretch it a certain amount x. Now it has a potential. Energy is not being used, it's being stored. You can think of potential energy as being stored. Kinetic energy is being used. All right. So now, lastly, what I would like to end this video with is the law of conservation. A mistake there. Conservation of energy. And what this states, you should become really familiar with this, because this is going to be very, very important for Physics 1, for first semester or quarter of physics. It just states that energy initial is equals to our energy final, that no energy is lost. It can be transformed from any of these forms into one another, or lost as heat, but not really lost, just transform into heat, but no new energy can be created. Of course, unless you introduce a different force, but then you're introducing energy at the same time, because they're related. It's the work energy theorem, which we'll talk about in another video. But for now, that just means that the potential energy on gravitational plus the potential energy on a spring plus your kinetic energy initial, of course, all initial, are going to be equal to, actually I'll change the color, energy final, will be equal to your potential energy gravitational final plus your potential energy on your spring plus your kinetic energy final. All right, so this is what the conservation of energy is. In our next video, we'll make a example. I think you guys will like it because it's a very classic example, and I'll show you guys. Also, one thing I forgot to mention here is that work is also a type of energy. So, and this many times is going to be included into here as friction. So work done by friction. And I'll show you guys how exactly that applies in our next video. So remember, leave your comments below, like us on Facebook, and subscribe on YouTube. Good luck with your studies.